Morning, all of you.
Good morning, sir.
Okay, what we discussed in the last class, we have solved some of the problems related to Colpitt's oscillator as well as RC oscillator. Later, we will discuss. We will solve so many problems on the various types of oscillators. Okay. Today we are going to discuss about the. We are going to start the unit 3. The title of the unit 3 is power amplifiers. Okay, first of all, we should know what is an amplification. What is an amplification?
The process of strengthening of waveforms.
Yes, the process of strengthening the signal. So we are the amplification is required. The amplification is useful to strengthen the signal which is applied as an input to the amplifier. Okay, it is going to amplify. So always we are going to concentrate on the amplitude of the signal. Is it right or not? So always we are wants to do the voltage amplification only. Okay, if you want to serve that particular amplified voltage amplified signal to the other output devices, that is not enough to serve. So in this case, what we have to do is, there is the requirement of power is very important. Maybe we are observing the signal as amplified in terms of voltage. For example, we are using one CA amplifier to amplify the signal. Maybe we are using another CA amplifier. Okay, means that if you use the one CA amplifier, it's a single stage, or one amplifier circuit for the signal. It's a single stage. Whenever we are using the 1, 2, 3 like amplifiers, it's simply called as a multi-stage amplifiers. Okay, we have discussed a multi-stage amplifier also in the previous classes. Maybe I think which oscillator it is. In the oscillator circuits, we have used two amplifiers. Which oscillator it is? Please tell me. So 180 degrees phase shift, 180 degrees phase shift, 360. Which oscillator circuit it is?
RC phase shift oscillator.
In RC phase shift oscillator, yes. So in RC phase shift oscillator, there is 180, 180 phase shift, there is a 360. Means that what happens? Here we are using two amplifier circuits, right? So simply it is called as a multi-stage amplification. So to obtain the sufficient required signal as a output, what we are ready to amplify that particular signal. Maybe it may be using single stage or it may be using multi-stage. But whenever we want to serve that particular amplified signal, the power, sufficient amount of power is also required. So in that manner, we have to amplify the power also. We have to amplify the power also. For example, at that amplified signal you want to give to the loudspeaker, it requires some amount of power in watts. But we doesn't have sufficient amount of power with us, with that particular amplifier circuit, with that circuit. So what happens? So you cannot reach the whatever the signal, amplified signal. Maybe it is voltage amplified, but power amplification is also required to serve the output devices. Maybe it may be loudspeaker or it may be any other output device. I think LE13, please switch off your video. I think all of you understood why power amplification is required. Am I audible to all of you?
Audible, sir.
Yes, all of you understood why power amplifiers are required? Sir, no more, raise your hands again. Okay, thank you. We'll see a small block diagram regarding to the power amplifiers. We'll start the class now. We will start with the very basics of this particular power amplifier. Then we will enter into the classification of power amplifiers. Then we will discuss. Yeah, my screen is visible to all of you.
Visible, sir.
Okay. Thank you. So this is the basic block diagram with respect to the amplification. Initially we are applying input signal to the microphone, then which is amplified. So voltage amplification takes place. We didn't get the or didn't obtain the sufficient signal. Then again it is applied to the another amplifier circuit. Okay, then which is going to apply to the power amplifier circuit. Then only which is given to the either we have here loudspeaker we have drawn, maybe the other output devices also. So means that voltage amplification is required to strengthen the input signal, as well as power amplifier is also required to apply the same signal to the any other output devices. I think all of you understood. So here we are using a BJT transistor. That amplifier circuit simply it increases the power level of the signal. Maybe it may be in the audio frequency range. We may call it as AF power amplifier, or it may be you may say that radio frequency range. It may be the radio frequency power amplifier. I hope you know what is the range of audio frequency.
2 to 20 kilohertz.
Yes, 20 hertz to 20 kilohertz. 20 hertz to 20 kilohertz is the range of the audio frequencies. Here there is a difference between the power amplifier as well as voltage amplification. There is a difference between those two. That's why we are discussing as a separate theory as power amplifier. And coming to the size of the power amplifier is also a little bit high compared with the normal transistor amplifier. And whatever the will get this power across the load, whichever is connected. That load is nothing but simply you can say resistor load. Okay, that resistive load at the output end, it may be also the very less load. It may be varies in between the 300 ohms to 8 ohms. Okay. And do you have any idea regarding small signal amplifiers? Small signal amplifier. Do you have any idea? So in the name itself it is there, small signal. At least now you can say. Hello. Am I audible to all of you?
Audible.
Yes, sir.
Please let me know what is a small signal amplifier. I gave hint also. The title itself.
Voltage amplifier, sir.
Why voltage amplifiers?
Small in amplitude.
Yes. So in the title itself, small signal amplifiers. So means that the input signal, whatever the input signal which is applied, it may be microvolts or millivolts. Microvolts or millivolts means that these type of amplifiers are deals with small input signals, small input AC signals, which is having the amplitude of microvolts or millivolts. So you know already voltage amplifiers input is almost in millivolts. Okay, and at the same time these type of amplifiers will work under linear portion of the transistor. Under linear portion of the transistor. I think I know. So I want to know that everybody knows whether the diode is a linear device or a non-linear device.
Non-linear.
whether the diode is linear device or non-linear device.
Non-linear device.
How you are saying? How you are saying?
It
It
works
does.
on forward bias and also in reverse bias, sir.
Ah, come again. Hello.
Characteristic stress spectrum, sir.
Sir, current flows in forward bias and as well as reverse bias also, sir.
You can say simply, for example, 0.3 volts is the cut-in voltage of the diode. Okay, so we are increasing the current, but there is no, see, by increasing the voltage there is no change in the current. Whenever it reaches to the diode cut-in voltage, then only it increases. So what is this portion? Hello. Please let me know. What is linearity? Hello. Please, if you don't want to say something, I also I'm not ready to say something. All of you, I am audible.
Yes, sir.
Sir.
I
Sir.
am asking
Yes,
questions,
sir.
but nobody is responding. So if you all are want to be like that, I am also want to be like that only. Thank you. And this portion called as non-linear portion. Why? Because I think everybody knows maybe about linearity with respect to the input signal, the output also may vary. So that is simply you can say as linearity. So here the diode works under non-linearity condition as well as in linear condition also. But everybody wants to concentrate on diode will works only in non-linear. But there is a linear condition is also there, that is after the cut-in voltage. Diode works with the property of linearity. And at the same time in the small signal amplifiers, we have considered as voltage amplification is come into the class of small signal amplifier. But in this voltage amplifier, there are so many parameters like gain, impedance, and some other parameters are also there, but these won't be changed. There is only change in the exclusively in the amplitude. Exclusively in the amplitude, that is small signal amplifiers. And when coming to the large signal amplifier, So this is also as in the title. So these large signal amplifiers are works with large input AC signals. So that's why these are called as a large signal amplifiers. And the example is power amplifiers. So these large signal amplifiers are to increase the or to provide the large amount of AC power. So then only there is a possibility to serve the signal to the output device. And here whenever we want to serve to the particular output device, we have to go with impedance matching. That impedance matching is only possible with the large signal amplifiers only, that too power amplifiers only. That's why we are discussing the power amplifiers. Almost it may be generate 1 watt power is large enough to provide these particular high signals, these amplified signals to the output devices. And coming to the differences between voltage and power amplifiers. For the voltage amplifiers, it requires high beta value and coming to the input resistance should be less than the collector resistance or collector load resistance. And at the same time collector current is small. Okay, these three are very important points with respect to the voltage amplifiers. Voltage amplifiers require high beta value and input resistance is less than the collector resistance, as well as collector current is also small. Whenever by coming to the power amplifier, here it may produce heat while transistors are in operation. And the base of the transistor is more thicker. Here transformer coupling is utilized. For impedance matching. I think all of you understood the difference between the voltage and power amplifiers. And now we will see with respect to the parameters, the change in voltage and power amplifiers. For example, if we draw a table, The first one is beta value. Beta value should be high. It may be greater than 100. And for power amplifiers, it is low, in between 5 to 20. And coming to the collector resistance, it should be high for voltage amplifiers, that is in between 4 to 10 kilo ohms. When coming to the power amplifiers, it should be low. It is in between 5 to 20 ohms. And coming to the coupling, here we may use RC coupling. But in this, transformer coupling. And coming to the input voltage, for voltage amplifiers, it may be low. Why? Because we have already discussed, it may be microvolts or millivolts. For power amplifiers, it is high, maybe 2 to 4 volts. And coming to the collector current, in voltage amplifiers, it is low, almost, which is equal to 1 milliamps. But here, which is high, greater than 100 milliamps. And coming to the power output, for voltage amplifiers it is low, for power amplifiers it is high. And coming to the output impedance, it is high for voltage amplifiers. Mostly it is 12 kilo ohms, and here it is low, it is mostly 200 ohms. Okay, these are the differences between voltage and power amplifiers with respect to the particular parameter. Might be, I am thinking that I don't want to ask the questions and I don't want to waste the time. So I hope that people are understand. Why? Because I think that if I concentrate for the interactive sessions in the class, in our regular class, I think that you are maybe in the active mode, but you people are not interested to be active. Okay, thank you. So I have to do my duty. So as per that, I will go on. And coming to the next concept, performance quantities of power amplifiers. We are always saying that compare with the voltage and power amplifiers. So in the voltage amplifiers, amplification is done in terms of amplitude, but when coming to the power amplifiers, we require or we have to produce more amount of power at the output. So in this context, we have to concentrate on the three performance quantities of power amplifiers. First one is collector efficiency, and the second one is dissipation, sorry, it is a distortion, and the third quantity is power dissipation capability. First of all, whenever we are talking about the collector efficiency, so always we have to get the maximum AC power at the output. And here what happens is, whenever we are discussing, whenever we are talking about the amplifiers which converts an AC power to DC power, whether you observed or not. So maybe we are saying that we have given the whatever the input signal with an amplitude as an AC, but whenever we are obtaining the output as a DC. So obviously the power is also which is going to be converted as AC to DC. So means that this is completely depends upon the collector efficiency. So simply say that it is the ratio of the AC power to input whatever we have applied. So simply we can say that the ratio of AC output power to zero signal power. Why we are talking about the zero signal power, which is from the power amplifier, is known as collector efficiency. I think all of you understood what is collector efficiency. So normally in an amplification process, we are converting, or that amplifier circuit converts AC power into DC power. Here in this case we are acquiring that particular DC power at the collector stage. Okay, so this whether we are getting a proper power or not, that is completely depends upon the effectiveness of the collector. So in this regard, this collector efficiency will be depends upon the AC output power whatever we are obtaining with respect to the zero signal power which is from the power amplifier. Okay, and the second one is distortion. Do you know what is distortion? Simply say that we are applying the input, whatever the input signal may be, maybe we are applying an input signal as a sinusoidal, but we are not getting a proper shape of that particular signal. So obviously we can say that there is a distortion. We can call that as a distortion. I simply say that the change of output shape from the input shape of the amplifier, you can call it as a distortion. And coming to the power dissipation capability, so we are saying that power amplifier produces a heat when the transistors are in operation. So obviously there is a power dissipation capability should be required because heat is going to be produced. I think all of you understood these are the performance quantities of power amplifiers. If you have any queries, you may ask before moving on to the classification. Do you have any doubts? Okay, thank you.
Distortion అనేది increase అవుతూ ఉంటుందా సార్?
That is depends upon the amplified circuit. For example, distortion is not increases. I'm just for example, I am mentioning that if you have considered a sinusoidal input signal as an input, whenever we are getting an output, the shape of the sinusoidal signal is changes. That is called as distortion. I think you understand.
Yes, sir.
I am not saying that distortion is increases. That is depends upon the type of the amplifier circuit. It may be the distortion whether maybe increases or decreases. Hope you understand.
Yes, sir.
Okay. This is an example. That's why I have drawn. There is a change in shape of the input signal. And coming to the classification of power amplifiers. When coming to the classification, we are saying that always power amplifiers will handle the large signals. But obviously, whenever we are applying an input, that input also, we already mentioned that it may be 2 volts, 2 to 4 volts like that. So in this, the transistor may be always in the saturation region. Is it right or not?
Yes, sir.
Whenever we are applying a low inputs, we have to check that when the diode or a transistor enters into the active region, all those things we have to check. Whenever we are applying a large amount of signal, obviously transistor goes on into the saturation region. So in this, depends upon the mode of operation, or maybe depends upon the collector current flow, we may classify the power amplifiers into 3 types. First one is class A power amplifier. Second one is class B power amplifier. The third one is class C power amplifier. So what is class A power amplifier? Do you have any idea?
No, sir.
So for example, you may have applied a sinusoidal signal as an entire signal, one cycle, to the class A power amplifier. The collector current flows entire cycle. The collector current flows entire cycle. So these type of amplifiers is called it as class A power amplifiers. Hope you understand.
Yes, sir.
Means that whatever the input you have applied, same output you will obtain. So means that the distortion, what about the distortion? Is there any distortion in this?
No, sir.
Might be there, it is low, very low distortion. When coming to the same sinusoidal input signal to the class B power amplifier, here the collector current flows only for the positive half cycle. The collector current flows only for the positive half cycle of the input signal. So obviously what happens, the input signal whatever you have given is the complete one cycle, but the output signal you have obtained only positive half cycle. So means that there is a distortion or not?
Yes, sir.
Yes, sir.
Yes,
Yes,
definitely there is a distortion. And when coming to the class C power amplifiers, same input signal I applied to class C. It is here the collector current flows less than the half cycle of the input signal. Means that it may be, let us assume that maybe. Now you just say that in which type of power amplifier distortion is high?
Class C.
class C, sir.
Class
C.
Yes, in class C power amplifiers are having high distortion. Compare with class B.
Class C and
Okay, class B is having high distortion. Compare with
Compared to class A.
class A. So I think now you understood the performance quantities, why performance quantities are important to obtain the more output power. Hope you understand.
Yes, sir.
Yes. So we may say that the same thing in terms of Q point. Do you know about Q point?
yes, sir. Operating point.
Yes, right.
Operating point at
Operating point. So which is VCE comma IC.
AC.
Okay. So coming to the class A, the operating point at the mid of the load line. So obviously what happens, we are getting the both cycles output. That's why we may say that it is at the mid of the DC load line for the class A. All of you understood?
Yes, sir.
Coming to the class B, it is VCE comma 0. VCE comma 0 means that it is at the in the line of 0 line, it may be for the class
Cut off region.
Yes, cutoff region, you may say that, but it works for one positive half cycle. And coming to the class C, the operating point at the negative axis. The operating point at the negative axis. Okay, so this is about the classification of power amplifiers in accordance with the collector current, flow of collector current. In the whenever the transistor is operated in the saturation region, we classified these power amplifiers into three types. One is class A, class B, and class C. So in which type of power amplifiers power dissipation is high?
Class C. Class C.
Power dissipation, I think collector current flows in the entire cycle. So obviously heat, much amount of heat will be produced. In which type of
Class A.
class
class
A?
A, sir.
Class A. And obviously collector efficiency is also class A.
Class A. Class A.
Class A, sir.
If you have considered these three performance quantities or might be the measures for all three types of power amplifiers. Hope you understand.
Yes, sir.
So we cannot say that distortion is zero. Okay, so yes, there may be the distortion, but it is very, very low. And there is a possibility of power dissipation. For the class A is there, class B is there, class C is also there. But we are saying that whether it is low or high. That's what we are going to say. I hope all of you understand.
Yes, sir.
Yes, sir.
Okay, and this is the introduction for the power amplifiers. From the next class onwards, we will concentrate on the each and every type of power amplifiers. Then we will analyze the every power amplifier. Okay.
Okay, sir.
Okay. Thank you all of you. Thank you.
Thank you, sir.